Good morning, students. Continue the discussion. In yesterday can be discussed some determinants, definition of determinants and some problems on the determinant. Today it's also continue the same types of problems in 2 cross 2 and 3 cross 3, in particularly exercise 4.1. So evaluate the following determinant. So first one is, observe these elements are enclosed in a form of determinant. So not in the matrix form. Therefore it just will be evaluate or then simplify. Suppose if these elements are enclosed in the form of matrices, now to find the values of the determinant. But if it is not necessary to mention the determinants, just will give that either evaluate or then simplification form. Now first one, value of determinants. How to find the value of determinant? 2, 4, minus 5, minus 1. That is one of the problem. Then we'll get just simplify. Otherwise, if it is also denoted by using the symbol delta, otherwise modulus of A means determinant of A, otherwise in the form of det of A. Any one of the symbol can be using in the values of the determinants. So product of, first will product of left diagonals. So left diagonals are nothing but 2 into minus 1. Product of 2 into minus 1 is minus 2. Between of right diagonal is put the negative sign. So procedure is product of left diagonal minus right diagonals. So first will product of left diagonal is minus 2. So between that values is nothing but sum of their negative value. And then right diagonals are minus 5 into 4. It's nothing but minus 20. That is minus 2 minus into minus is plus 20 is equal to 18. So that is the values of the determinant. It's denoted by delta. So similarly, second problem. Determinant of cos theta minus sin theta, cos theta. So again, if it is denoted by delta is equal to product of left diagonal, cos theta into cos theta can be written as cos square theta minus sin theta into minus sin theta. Sin theta into minus sin theta is nothing but minus sin square theta. So after that, cos square theta minus into minus is plus sin square theta. So by using that property, if it is nothing but 1, cos square plus sin square is 1. Therefore, the values of that determinant is nothing but 1. Then third one is x square minus x plus 1, x minus 1, x plus 1, x plus 1. Again will be product of left diagonals. X plus 1 into x square minus x plus 1. In the right diagonals are x plus 1 into x minus 1. So then we'll get distribute. X into x square is x cube. X into minus x is minus x square. X into 1 is x. Plus 1 into x square is x square, 1 into minus x is minus x, plus 1 into 1 is 1. Similarly, in the second is also possible to get distribute. Otherwise, by using the formula, these two are in the form of a plus b into a minus b. It can be written as a square minus b square. So then we'll get simplify. X cube minus x square plus x square. Both are get cancelled. X minus x is also get cancelled. That is plus 1 minus x square minus into minus is plus 1. But if these two steps are also can be written as in the form of a plus b into a square plus b square minus ab. That is in the form of that steps is also can be written as x square plus 1 is can be written as 1 square minus x can be written as x into 1. Into that product is x plus 1. Now these are in the form of a plus b of a square plus b square minus a into b. That is an expansion of a cube plus b cube. If it is also by using their expansion, otherwise just will expand the product of multiples of 2 factor. X into x square is x cube, x into minus x is minus x square, x into 1 is x. 1 into x square is x square, 1 into minus x is minus x, 1 into 1 is 1. After that minus x square plus x square are get cancelled, plus x minus x get cancelled. Remaining is x cube plus 1. And the second term is minus x square minus into minus is plus 1. So that is also can be written as x cube minus x square plus 2. that is one of the value for the delta or determinant. We'll see. Next one, if matrix A equals 1, 2, 4, 2, then to show that determinant of 2 into A equals 4 times of determinant of A. So now we will observe them. A is one of the matrix of order 2 cross 2. So now to show that. So first we will consider in the LHS. What about the determinant of 2 into A? Therefore, first we will 2 into A. So 2 into A means if all the elements of A are multiplied by 2, that is called as one of the scalar multiplication of a matrix. So what are the elements of the matrix are multiplied by 2. That is 2 into 1 is 2. 2 into 2 is 4, 4 into 2 is 8, again 2 into 2 is 4. So then determinant of 2 into A, therefore these elements are enclosed in the form of determinant. So in terms of matrices can be enclosed in the form of determinant, that is 2, 4, 8, 4. So we will get simplified. Now first we will product of left to diagonal. Left to diagonals are 2 into 4 is 8 minus product of right to diagonals 8 into 4. So then we will get subtraction. So 8 minus 32 is nothing but minus 26. Minus 24, that is in LHS, otherwise it will be called as an equation 1. So similarly in RHS, RHS is 4 times of determinant of A. So 4 times of determinant of A. Therefore, so first we will find determinant of A. So determinant of A means matrix A can be reduced in the form of determinants. So elements are 1, 2, 4, 2. So get simplified. So their values is nothing but product of left to diagonal is 2 minus product of right to diagonal is minus 8. So 2 minus 8 is equal to minus 6. Therefore 4 into determinant of A, 4 into determinant of A is 4 into values of determinant of A is minus 6. So 6 into 4, it will be equal to minus 24. And let be called as an equation 2. So then comparing in equation 1 and 2, these values are nothing but same. Therefore, determinant of 2 into A is equal to 4 times of determinant of A. So similarly, the next one is matrix of order 3 cross 3. If A equals 1, 0, 1, 0, 1, 2, 0, 0, 4. Then to show that determinant of 3 into A is equal to 27 into determinant of A. So now first we will consider in the LHS determinant of 3 into A. Now consider first we will 3 into A. So 3 into A means if all the elements of the matrix A are multiplied by 3, that is elements are 3, 0, 3, 0, 3, 6, 0, 0, 12. That is 3 into A. After that by using the determinants. Determinant of 3 into A. Therefore these elements are enclosed in a form of determinant. Determinant of 3, 0, 3, 0, 3, 6, 0, 0, 12. So get simplified by using the condition of 3 cross 3 determinant. So first we will put the symbols on the first row. It can be expand using in any rows or in any columns, but in the previous classes now is always expand along the first row. It's also continuing in the first row. So 3 off. That is first we will reduce it in the form of 2 cross 2 determinant. In case of 3 cross 3 determinant can be reduced in the form of 2 cross 2 determinant. So first element is 3. After then we will get neglected what are the elements of rows and the columns along with the elements. So remaining elements are nothing but 3, 6, 0, 12. elements of first row and first columns are get neglected, and the remaining is nothing but 2 cross 2 determinants can be represented in the form of determinant. Similarly, the next element is nothing but 0. Again, 0 is an element of the first row and second column. 0 is an element of first row and second column. Again, these are get neglected, and the remaining is nothing but 0, 6, 0, 12. Similarly, in the third element is 3. So 3 is an element of first row and third column. 3 is an element of first row and third column. These are also get neglected, and the remaining elements are nothing but 0, 3, 0, 0. So then we'll get simplify. 3 of. To remove the symbol of determinant by using the bracket, 3 of. Product of left to diagonal. So 3 into 12. 3 into 12 is 36. Minus product of right to diagonal is nothing but 0. 6 into 0 is 0. So similarly, for the next element, 0 of. Product of left to diagonal is 0. Similarly, right to diagonal is also 0. And third one is 3 of. Product of left to diagonal is 0 and right to diagonal is also 0. So get simplify. 36 minus 0 is nothing but 36. 36 into 3 is 108. The next element is 0 into multiple is also 0 is get 0. Again 3 into 0 is also 0. Therefore, the values of LHS means determinant of 3 into A is 108. So dear students, if these steps are not necessary to mention in all these problems, in the second step means 3 cross 3 determinant can be reduced in the form of 2 cross 2 determinant is not necessary to mention in all these problems. So if it is only for your reference, if it is possible to avoid these steps, will directly can be written as in the third step. So the same steps can be continued. So discuss in the next problem how to get avoid or the second order determinants. So in their RHS, so consider in their RHS 27 into determinants of A. 27 into determinant of A, that is in the RHS. So therefore, so first we'll find then determinant of A. So determinant of A is 1, 0, 1, 0, 1, 2, 0, 0, 4. But in that problem, how to avoid the second order determinants? In all the problem, if it is possible to avoid these steps, so directly we'll come to the third steps. So we'll continue in these problems, how to avoid in the second step. First will, if all the elements of the first rows are get multiplied by using the symbols of the determinant. So in first row particularly plus minus plus, in second row 0 plus negative plus negative, and in the third row plus minus plus. So first element is nothing but 1. So after that, so if these rows and columns are will be closing by using in our hands or then any some another pens or any symbols. So in the remainings are nothing but will be once will read. So elements are nothing but 1, 2, 0, 4. So remaining elements are 1, 2, 0, 4. Then these elements are directly get cross multiply. 1 into 4 is nothing but 4. Left, right diagonal 2 into 0 is 0. It's not necessary to mention the second order determinant. Similarly, next element is 0. So 0 is an element of the first row, second column. 0 is an element of first row and second column. These elements are also closing like this. So in the remaining elements can be once will read with 0, 2, 0, 4. After that by using their cross multiplication, 0 into 4 is nothing but 0 minus 2 into 0 is also 0. Similarly, third element is nothing but 1. So 1 is an element of the first row and third column. These are also get neglected, and the remaining elements are nothing but 0, 1, 0, 0 and get cross multiply. Left diagonals are 0, right diagonal is also 0. 0 minus 0. So after that 1 half 4 minus 0 is 4. Minus 0 of 0 plus 1 into 0 is also 0. It will be equal to 4. That is the value of determinant of A. So after that 27 into determinant of A is 27 into 4. It will be equal to 108. So that is an RHS. We will comparing with both LHS and then RHS. The values will be equal. Therefore, determinant of 3 into A is equal to 27 into determinant of A. So that is some basic properties of scalar multiplications of the matrices. So students, to remember the one of the statement, it's an avoid the previous problems to how to avoid the steps calculations of the basis. So one of the properties of the determinant of k into a is equal to k to the power of n into determinant of a, where n is called the order of the matrix. So we will be consider in the last exam, a is 3 terms of a is equal to 27 into determinant of a. So in the problems now to show the both LHS and then RHS will be equal. But in particularly, how to find one sides of the determinant, how to find the 3 times of determinant of A. So you will already know that one of the method is if all the elements of A are multiplied by 3, after that by using the properties of the determinant. But if it is not necessary by using their procedure, by using one of the properties or some shortcut form of the determinants. So determinant of k into a is equal to k to the power of n into determinant of a, where n is called the order of the matrix. So in the second problem, where a is nothing but one of the matrix of order 3 cross 3, that is 1 0 1 0 1 2 0 0 4 in the last problem. I will take the last problem. The same problem we will give the examples of that property, where a is nothing but 1 0 1 0 1 2 0 0 4 is a matrix of order 3 cross 3. Now first we will find the values of determinant of A. So determinant of A is nothing but, in the first row can be choosing in your expansion by using the symbols or sign of the determinant plus minus plus. So 1 is an element of the first row and first column, and these elements are get neglected, and the remaining elements are in the form of 2 cross 2 determinant. So just multiply in the product of left to diagonal minus right to diagonal. Left to diagonal is 4 minus right to diagonal is 0. Similarly, next element is 0. 0 of 0 is an element of the first row and second columns are get neglected, and the remainings are just cross multiply. 0 into 4 is 0 minus 2 into 0 is also 0. So similarly, third element is nothing but 1. So 1 is an element of the first row and the third column. Remainings are get multiply with each other. These are in the zeros. So after that, if it is nothing more 4. So 1 into 4 is 4, that is the values of the determinants. So then to find the values of 3 into A, values of 3 into A by using that properties of determinant. In the last problem can be simplified by using the condition of scalar multiplication. 3 into A means if all the elements of A are multiplied by 3. But in this problem, by using the properties of determinant, it can be written as, if these two are comparing with each other, so A is nothing but A, but K is nothing but 3. So therefore, by using in an RHS, K power of n means 3 to the power of n. So where n is called the order of the matrix. In the given matrices, order is nothing but 3 cross 3. Therefore, n is equal to 3. Therefore, 3 power of 3 into determinant of A. But values of determinant of A is nothing but 4. So 3 cube is 27 into 4. 27 into 4 is nothing but 108. So answer is already known that in the previous problems. So that is the solution of 3 into A without using in their calculation some properties on the basis on the properties of determinant. So it's one of the shortcut form of the how to simplify the scalar multiplications of any determinants. So therefore it's one to remember the statements. Determinant of K into A is equal to K to the power of n into determinant of A, where n is called the order of the matrix. We'll see. Similarly, some problems on the basis of these properties. If A equals 0, minus 1, 2, 4, 6, minus 5, 0, 1, 2, then find determinant of 5 into A. So, we'll already one of the method will be known. 5 into A means if all the elements of 5 are multiplied, A is multiplied by 5, after then by using to find the values of determinants. But by using the properties of determinants, only first will simplify the values of the determinant of A. Therefore, determinant of A means if all the elements are represented in the form of determinant 0, minus 1, 2, 4, 6, minus 5, 0, 1, 2. So, again first we will put the alternating sign in the elements of the first row. So, first element is nothing but 0. Again if we avoid the representation of 2 cross 2 matrix, directly will simplify it in the determinant form. Now if 0 is an element of the first row and first column, and these elements are get neglected, and the remaining elements are nothing but 2 cross 2 determinant. These two are get simplified by using their cross multiplication. First will left to diagonal is nothing but 12 minus right to diagonal is minus 5 into 1 is minus 5. After that minus into minus is plus 5. So, some problems will be practiced if it is easy to get simplified in the direct forms. So, similarly, next element is minus into minus. Minus into minus is nothing but plus. We will already one of the negative values in the given elements. After that sign will be applied in the first row. After that minus into minus is nothing but plus. Then 1 is an element of, that minus 1 is an element of first row and second column, and these elements are get neglected, and the remaining elements are by using cross multiplication. So what are that elements are will be remaining? 4 minus 5 are the first row, 0, 2 are the second row. Get cross multiply. 4 into 2 is 8. Minus, right to diagonal is minus 5 into 0 is minus into minus plus 0. Similarly, third element is nothing but 2. So, 2 is an element of first row and third column. 2 is an element of first row and third column, and these elements are get neglected, and remainings are get multiplied. 4 into 1 is 4, minus 6 into 0 is 0. So, then we will get simplify. 12 plus 5. So, 12 plus 5 is 17. 17 into 0 is nothing but 0. Next element is 8 plus 0. 8 plus 0 is 8. 8 into 1 is 8. 4 minus 0 is 4. 4 into 2 is 8. So that is 8 plus 8 is 16. That is the values of determinant of A. So after that to find values of determinant of 5 into A. So by using that property, determinant of K into A is nothing but K power of n into determinant of A. By using that property, that is K means 5 to the power of n. So where n is called the order of the matrix. That order of the given matrix is nothing but 3. That is 5 to the power of 3 into determinant of A. K power of n into determinant of A. So therefore in the given values, determinant of A is nothing but 16, and 5 cube is nothing but 125. That is 125 into 16. So after that get multiply, it will be equal to 2000. So that is the values of determinant of 5 into A. So similarly, next one is a matrix of order 2 cross 2. Again first we will find determinant of A. So A is nothing but 2, 4, 5, 1. So first we will get multiplied in the 2 cross 2 determinants. Product of left to diagonal is 2 minus right to diagonal is 20. So dear students, we'll observe one of the point in only for the 3 cross 3 matrices is multiplied by using in an alternating sign, but it's not necessary in the 2 cross 2 matrix. In 2 cross 2 matrix, if it is directly multiplied with the left diagonal and right diagonal, but in 3 cross 3 matrix, first we'll apply the symbol in which of the row will be using in your expansion. First row can be, suppose we'll be using in the first row by using the signs are plus minus plus, suppose in the second row minus plus minus, and in the third row plus minus plus. These are applicable only for the 3 cross 3 matrix. It's not in the 2 cross 2. 2 cross 2 is directly get multiplied product of left diagonal minus right diagonal. That is 0 minus 20 is nothing but minus 18. That is the values of determinant of A. So then we'll come to the 2 terms of determinant of A. Determinant of 2 into A. So by using that property, it can be written as 2 power of 2. So 2 is nothing but order of the matrix. So 2 power of 2 into determinant of A. 2 power of 2 is 14 into minus 18. So after that multiplication is nothing but minus 72. That is the values of 2 into determinant of A. We'll see. Next one, evaluate the following. Again, simplify in the some examples. First one, 3 minus 1 minus 2, 0, 0 minus 1, 3 minus 5, 0. Again, first we'll denote it by either in determinants of A, otherwise by using the delta. Suppose if it is denoted by using the symbol for A, first we'll denote it by the given matrices are in the form of A. Otherwise, by using the values of determinants can be called as delta. So delta is equal to, we'll be choosing in the elements of first row, therefore by using the alternating sign, plus minus plus 3. Now 3 is an element of first row, first column. 3 is an element of first row and first column. So in the remainings are in the form of 2 cross 2 determinants. Get simplified by using the cross multiplication. Left diagonal is 0. Minus, that is a formula for the minus for formulas, minus product of right diagonal, minus into minus is nothing but plus 5 into 1 is 5. So we'll always observe it, product of left diagonal minus right diagonal. That minus is always between of product of left and the right diagonal. Similarly, second values is nothing but minus into minus is plus 1. So plus 1 is the value for element of first row, second column. 1 is an element of first row, second column, and these values are get neglected and the remainings are get cross multiplied by using the 2 cross 2 determinants. So left diagonal is 0 minus right diagonal is nothing but 3 into minus 1. 3 into minus 1 is minus 3. After that minus into minus is plus 3. So formula don minus values aliranthadu innond minus. Minus into minus is plus 3. The last element is minus 2. Minus into plus is minus 2. So minus 2 is an element of the first row, third column, and again these are get neglected and the remaining element is nothing but product of left diagonal is 0 and right diagonal is also 0. 0 minus 0. Get simplified. 3 of 0 minus 5 is minus 5 plus 1 into 3 plus 2 into 0. That is minus 15 plus 3. It will be equal to minus 12. That is the values of first value. So similarly, for the next matrix determinants 0, 1, 2, minus 1, 0, minus 3, minus 2, 3, 0. Again by using the alternating sign for the first row. So delta is equal to, it's an element of first one is 0. So 0 is an element of the first row and first column and these are get neglected and the remaining is nothing but 0 plus 9. But if it is also not necessary to mention of that values, because if the multiple number is nothing but 0, 0 into anything will be 0. If it is also possible to avoid these elements. So similarly, minus 1 of. So minus 1 is an element of the first row, second column and these are get neglected. So in the remaining are nothing but minus 1, minus 3, minus 2, 0 and these products are 0 minus, it's a value sign for the formulas, and the product of right diagonal is nothing but plus 6. The plus into minus is minus 6, and the third element is 2. So 2 is an element of the first row, third column. 2 is an element of first row and third column, and these are get neglected, and the remaining is nothing but minus 1 0, minus 2 3. These products are minus 3, minus 0. Get simplified. So first one is nothing but 0 because its a multiple is also 0, and the second one minus into minus is plus 6, and third one is minus 6. So then their addition is also 0, that is the values of the determinants. So similarly, we will come to the third problem. So determinant of 2 1 1 minus 2 1 minus 3 5 4 0. So delta is equal to 2 of, first we will put in their sign, 2 of. 2 is an element of first row and first column. 2 is an element of first row and first column, and these elements are get neglected, and the remaining elements are in the form of 2 cross 2 determinants are get multiplied. In the left diagonals are 0, minus, right diagonal is minus 12, after that minus into minus is plus 12. Similarly, next values is 1. So 1 into minus is minus 1. 1 is an element of the first row, second column. 1 is an element of first row, second column, and these are get neglected, and the remaining are get cross multiply. 0, minus, right diagonal is minus 15, that is minus into minus is plus 15, and third element is nothing but 1. So 1 of, 1 is an element of the first row, third column. Again these are get neglected, and the remaining are get cross multiply. Minus 2 into 4 is minus 8, and 5 into 1 is minus 5. So get simplify. 2 into 12 minus 1 into 15 plus 1 into minus 8 minus 5 is minus 13. So 2 into 12 is 24. Minus 1 into 15 is 15, minus 1 into 13 is minus 13. So minus 15 minus 13 is minus 28, minus 28 plus 24 is minus 4. So that is the values of that determinant. So these are the some simplification form of 3 cross 3 determinants. Next one, find x, that is denoted by using the small letter. So x is denoted by using small letters if it is called as element of the matrix. So if 2, 4, 5, 1 is one of the value for the first determinant, 2x, 4, 6x are the elements of the second determinant. So by using these two determinants, how to find the values of x? Suppose if these two are enclosed by using the condition of matrices, what about the definition or condition of equality of two matrices? So if any two matrices are called as an equal, if and only if their corresponding elements are directly equating with each other. But in the case of determinant, if it is not exist, in case of determinant, corresponding elements are not equating with each other. What about the values of the determinants on both LHS and RHS are equating with each other. But in only particularly in case of matrices, so corresponding elements are equating with each other, but it's not in the determinants. So it's always remember. So equalities of two matrices means any two matrices are equating with each other, those corresponding elements are will be equal. First row is equal to first row, second row is equal to second row. But in case of determinants, such a particular values of the determinant means last solutions of the determinants are equating with each other. So not equating in the corresponding form. So elements of the first determinant is 2, 4, 5, 1, and the second determinant is 2x, 4, 6, 2. So first we will get simplified in both of the determinants. Product of left to diagonal is 2 minus right to diagonal is 20. So similarly in their RHS, product of left to diagonal 2x into x is nothing but 2x square minus right to diagonal 6 into 4, 24. But it's always remember that values are not correspondingly equal to each other in case of determinant. But in case of matrices, if it is possible to equating with their corresponding elements. So after get simplify. 2 minus 20 is nothing but minus 18. is equal to 2x square minus 24. So after that can be solving in the form of simultaneous. What are in place of x square are in their one side and the remaining constant can be transposed into their another side. That is minus 18 plus 24. Minus 24 can be taken as in the left hand side is nothing but plus 24. Minus 18 plus 24 is nothing but 6. So 6 is equal to 2x square. Therefore, x square is equal to 3. Then x is equal to plus or minus root 3. The values of x is equal to plus or minus root 3. So similarly, the next condition is if 2, 3, 5, 4, 4, 5 are the values of the first determinant equal to x3 to x5 are the elements of the second determinant. Again equating with the values of the determinants in both LHS and then RHS, not for the corresponding elements. So first we'll product of left to diagonal. 2 into 5 is 10 minus right to diagonal 4 into 3 is 12. It will be equal to again product of left to diagonal x into 5 is 5x minus product of right to diagonal 2x into 3 is 6x. 10 minus 12 is minus 2. 5x minus 6x is minus x. These minus minus are get cancelled. Therefore, the values of x is equal to 2. That is another one of the problem. Similarly, third one. So, elements of the first determinant is x to 18x and in their RHS is 6 to 18, 6. So, left to diagonal. Product of left to diagonal is x into x is x square minus 18 into 2 is 36 equal to in the right diagonal 6 into 6 is 36 minus 18 into 2 is also 36. Therefore, x square minus 36 is equal to 36 minus 36 is 0. Otherwise, minus 36 are get cancelled on both sides. And the remaining is x square is equal to 36. Therefore, x is equal to plus or minus root 36. Root 36 is nothing but x. These are the values of the x. So these are some problems on the 2 marks question for the annual examination. It's the most important problems. So work out these some another problems are in the homework problems.